own. And how do I get started? So not to worry, we also will send all of you here, whatever attend today, all my training material. So we can play with that and later, including this PowerPoint. So you can use it in classroom also. Of course, I had to show how do I get started. So not to worry, we also will send all of you here. Okay, so you will not be you do not have to use this PowerPoint about my pictures, but you can recycle anything else that up to you. I myself have been 25 years in the industries and doing a lot of consultings and implementations, and I completed nearly about 100 over industrial projects. Yeah, is 100 seems like not many, but many other projects might take about 3 months to even 3 years. That's why sometimes some of the project will take longer time. So in the past 25 years, then we cover a lot of projects actually come from countries like Thailand, Malaysia, Singapore, Indonesia, and all the way to Taiwan. So there are a lot of small all the way to medium and MNC company are all our clients. So that's why I'll share with you things more on a practical sense, because these are not from a classroom or textbook per se, but we actually explain them more in a very practical way, what's happening in the real world in a very relevant way. And the important thing is today, when you are here for AI, so I have to share with you about market value. Why does it matter? So according to the latest research just a few months ago by Forbes International, and they say that for year 2022, 99% of all industries, this survey was taken among all the industries in the US, 99% of them will invest a lot in machine learning and AI in an unprecedented way. Unprecedented means that they never invest this much before. These are their projections, yeah, for 2022, being this year, yeah. And also important thing is in a short future to come, less than 3 years from now, the projection is about 126 billion of revenue related to AI business. Either is investment, either is actually transactions between consumer and developer, things like that. Any AI-related technology revenue will be 126 billion. There's a lot of zero behind. So there's a major disruption, not just for IT company, but actually you could see the survey here. It cut across almost all disciplines or industries. For hotel, advertisement, recreation, all the ways from consumer, energy, food and beverage. This whatever actually business you are in. Now, AI is not something new. As early as 1950, it started already. Of course, people call it artificial intelligence. It sounds like rocket science. But in come to actually about 1990s, especially in past 10 years, what not spin off, actually in a way people call more specifically in practical way as a machine learning. Machine learning doesn't mean it's robotic learning. It means actually machine refer to computer. Computer learn and how to derive and how to come out with prediction more accurately with little programming we call machine learning. Yeah. So this is something that happened a lot in past 10 years. But in Malaysia, actually machine learning only come to industry more frequently, actually less than 5 years. So 10 years ago, there are some big companies, they talk about machine learning, but that was on the top elite or engineering team. Some of them did mention about that. For instance, 10 years ago, Intel, they approach and say, how do we do machine learning to analyze our customer behavior? Yeah, but not many other companies talk about that. But in recent years, deep learning is in a way, you do not have to define your independent variables that much. It's not the easy program, but once you program, make it work, you automatically extract what the independent variables are. That means that you do not really have to define what's the problem in a very precise way. And it involves multiple layer neural network. So it makes actually whole things become very easy for end users like you and I. For instance, if you look at deep learning, right, our day-to-day using will be like voice assistant in your handphone. Yeah, you just command them a lot of things like smart home, smartphone, or using voice command. Yes, what you saw in the movie 20 years ago now actually something that we are using day-to-day basic. Auto translator, Google. We are using every day. Visual translator, yeah. Auto drive car is coming to Malaysia very soon. That this is very common actually in the US, in the China. If in the US already on the road for 6 or 7 years already. Now, visual recognition, either as a videos, either as images or pictures. These are all involved deep learning. Yeah. But if you look at all the left-hand side, machine learning actually started much earlier. Yeah. It involves, for instance, the typical use is predictive marketing in the business world. Predictive business, predictive operation, predictive maintenance, predictive engineering. The keyword is predictive. So the good thing is machine learning requires little program. Yeah. And if you compare both of them, if you look at them, both of them have very powerful implication in the different areas of application. I look at the deep learning where usually it has to deal with big data. The data speed it coming and the amount it coming is massive. It's not something that ordinary people like you and I can make use of this deep learning very easily at home. Yes, some application, yes, we could do that too. I will show you how we can do deep learning on a desktop. But the limitation usually involved, if you want to make it very productive and effective one, for commercial use, the investment in the skills, talents, and hardware is usually quite big. But look at the other hand, machine learning is using ordinary data set. Think as simple as text file, CSV file, normal, ordinary is a commercial database. With the reasonable fair amount of investments in the hardware, software, and some of the skill, people will benefit from that a lot. But this is something many of us do not realize, especially in Malaysia. Now, let's take a look. Our actually concept usually comes to AI. Usually we look at the deep learning part. Yes, this thing is something that not unusual to many production line these days, especially in the MMC, because they need to use video capture, not to surveillance, but they want to transfer it into something that computer can discern, understand the behavior and the patterns, what it captures. To come up with conclusion, come up with alert like that. Yeah. Now, later I will also show with you how we can do that. Of course, I will not show it in a very intensive video part because it involves a lot of memory. Now, let's take a quick look. What can AI, particularly in machine learning, it could do for us? I'll share with you 4 examples today because these 4 examples easy to understand. Yeah, it might not cover all discipline that you wish to see, but in our actually full-fledged workshop, you'll cover nearly 15 different case studies. Today, only share with you 4 the basic one. For instance, how we do customer analytics, how we do pricing analytics, how we do maintenance analytics, how we do engineering analytics in a 4 simple approach. Yeah. Now, let's take a look first. Now, if you want to apply AI machine learning, what is the concept behind? Like I say, this is low-hanging fruit. Investment in hardware and data set is fairly small. Yeah, it's fairly small. For instance, if you have a data set like that, either in your database on your simple data set like CSV file, text file, Excel file, about your customer, how you describe customer. The way you describe customer, usually you cannot run away a few things. This kind of information these days, for any company who are interested in developing long-term marketing, usually they'll keep this data in a system called Customer Relationship Management, CRM. Any company, like say, again, they are serious developing long-term marketing strategy, they have to keep a CRM. Either the CRM is simple as keeping an Outlook, is one way of doing CRM, or keeping in a specific cloud-based accounting or CRM, specially designed for CRM purpose. This information has to be made available from the top management all the way to the marketing people on the field. For instance, you need to know what's the income of a customer, what kind of car or vehicle they are driving, what kind of house they're living in, what's the credit they have, what's the saving pattern, what's the consumption pattern they have, what is the value they're contributing to your organization in the past, what kind of products they have been buying from you, what kind of purchasing patterns they have. Do they buy during Hari Raya, Chinese New Year, or Deepavali, or they buy all season or day, or they consume more during the middle of the year, or they consume only by the year end when they receive bonus. These are all patterns. Yeah. So based on these patterns, can you actually come out with a conclusion? Because everyone, if it could be like mathematically actually analyze and come with a pattern, quite likely we can identify certain people that we wish to identify. For instance, in this case, business people care about VIP. Yeah. So those people who do not bring much value, if they become the customer, usually their cost be higher. For instance, if I only purchase 100 ringgit per year, my cost to be maintained by the company will be relatively high. They need to send me brochure, they need to talk with me, they need to entertain me, the support. So these are all customers maybe that will not be contributing that much of cost and value to the company, but rather the company say, hey, I want to focus on the VIP. I want to focus on VIP. Who will be the VIP might not actually based on how much I have purchased in the past. Because if I have purchased 100 ringgit in the past, it doesn't mean that in the future or coming year, I will not buy 100,000 from you. So if you can identify a very potential VIP, not based on your past purchasing volume per se, but it can predict how much they're going to actually contribute, who will contribute the most to you in future. Wouldn't it be wonderful? You will focus talking to these people. Now, on the other hand, if I want to do a pricing predictive, why does it matter? For instance, this is one typical example. Housing, because it's very important, especially after a flood, government give out a lot of incentive for people to make available for those people destroyed by the flood. But even before a flood, having a proper housing in Klang Valley or in the city in KL is always a headache. So in this case, if I want to buy the house, if I'm selling the house or flat, apartment, condo, what would you ask? You say how big the area is, where the location, what type of the housing, and where it's near an LRT traffic jam or not, got parking space or not, how much I need to pay for those, got school or not, shopping center near or not, got this taman near that side or not, the hospital nearby or not. You're asking all these kind of questions. When you're asking all these kind of questions, you're not looking off the area, the built-up area of building per se. You're looking at some of the intangible things. Intangible means incalculated things like population, security. In this case, isn't it good if you have a system based on a past historical database can immediately tell you that even without a consultation of an expert, real estate expert, the computer will tell you right away how much you should pay for the price or how much you should offer. This is how machine learning, predictive analytics will do. So in this case here, you might be wondering, how does it work now? How come it work that way? It sounds too wonderful. Now, if you think back a simple thing, right? If you want to know how much a housing price, or any price, car price, and anything products all in the market, usually it's determined by certain feature. Feature in this case, actually mathematically, we call independent variable. Independent variable is, in this case, built-up area. The bigger the area is, the more you need to pay or are willing to sell. So in machine learning or AI, area, this thing called independent variable mathematically, we call it feature. This is one feature. One feature is area. The bigger area is usually the price will go up. But now, in reality is you can draw not necessarily linear line. Sometimes the line itself is non-linear. For this case, we might not be able to plot y equal to ax plus c. It's ax squared plus bx plus c. It's something like maybe multiple terms. But to make things more complicated, like I say, people do not consider built-up area per se. They look at, is it nearby LRT? Do we have free parking space? Is it actually close to hospital because I have elderly at home? Some of those things I consider are non-tangible or not really calculated in value one. So putting on this, not just X only, you have X2, X3, X4, X5, X6, X7. So then mathematically, with thanks to AI, they have many algorithms developed this day. In the past, that only need to require supercomputer calculate, but now they come very efficiently to be achieved in the desktop like what you're having right now. How does it work? I'll share with you in a short while. Now, I'll come back here. Now, sharing the screen right now using Wolfram Mathematica desktop version. So of course that if you say, hey, I have desktop version installed, wonderful, you can go along with me. Now, sit back first and observe how it works. During the practical time, I'll give you some code so you can play with that. But we say, hey, Peter, I have received the activation code from you, but I have not had a chance to install yet. Then what should I do? Now, this is a little link here. I'll put in the chat room. Yeah, you can actually open it now. If I put in chat room, you open it. This is a cloud version, free one. This cloud version allows you to play with certain computation. Yes, when I say certain computation means that if you want to run a very complicated machine learning that maybe the system will take like 1 minute to run, it will not be possible because this is a free version. But if your computation itself only involves like 30 seconds, because or 10 seconds, the system will give you the output just like a commercial version. So it becomes sandbox for you to play with. For those actually who came for the very first time to see Wolfram Mathematical Technology, a quick tips how to get started. Yeah, this is a link I put in the chat room already. You click on that, it give you this like that. If you ask you to sign up, you can take your time, sign up later. Once you sign up, for instance, here, I'm interested in normal calculator, 1 + 1. Yeah, 1 + 1. After that, you see here on top here, little button here called evaluations here. Yeah, you just click evaluations. The system now asks you what do you want to evaluate. You can click evaluate cells or evaluate all cells, no issue. Now just click evaluate cells. Yeah, so the system start running. In Wolfram Mathematica, this is one of the things they pioneer. Yeah, they combine everything. Everything means presentation, coding, computations, visualization, everything inside one. We call it notebook. In a notebook here, in order for the system to understand which one is meant for computation, which one is meant for word processing, which one is meant for presentation, they need to break them down into brackets or cell. So this is called one cell. So inside this cell here, the system understands by default, whatever I type is computation. So you click evaluation, you evaluate cell by cell. So we could have hundreds or thousands of brackets of cell inside a notebook. You can selectively choose to go to any cell to evaluate as one. So this thing is not like reading a newspaper or reading from top to bottom like that, or procedural programming. Once you run from the top to bottom. No, every cell itself is independent computations. You can choose any single bracket of cell to evaluate and compute it and run it accordingly. So this one becomes very versatile. So a lot of programming language this day on market, they start following Wolfram technology. They call it notebook. When you hear the word notebook, then it means actually them running things in cell. Yeah, something like that. Now, let's come back here to what we have on my desktop version. So you do not have to do anything just yet. You should look at actually how I'll demonstrate to you the concept of Wolfram Mathematica AI machine learning makes simple to every one of you. Now, let's see. When talk about predictions, there are actually three things that today I'll share with you. Yeah, when it comes to AI machine learning, there are several categories, but I do not want to confuse you with the names of categories because that could be first time for you to hear about machine learning in the field of AI. So rather, I share with you only three things. First thing is called regression. Yeah, in Wolfram, we call it prediction. Prediction, how come? But we call it regression. Regression is more mathematical terms. Yeah, how do we actually plot a line to display the relationship between X and Y? Yeah, we call regression. Secondly, we call classification. And third thing I'd like to share with you today is called clustering. Yeah, hey, what's this thing? Not to worry, regression, classification, and clustering. I'll share with you one by one how come it's relevant to you. Now, first thing, if you have the data set like this, simple one. This data set, it means actually I have a feature on the left-hand side, or mathematically we say we have an x equal to x result in y like this. We have x, y, x, y, x, y. But we separate with the arrow sign. So it means actually follow the syntax of machine learning, a feature with the output value, feature output value. So 1, 2, 3, 4, 6. These features represent on the left-hand side will result with output value on the right-hand side. So as simple as like that, we call it as data. So if I run this thing as data, okay, then the next thing I say, can you help me do a mathematical regression? So in a Wolfram, we call predict. Actually, it's the same thing like mathematically doing regression. It simply helps us come up a very simple formula. Yeah, y equal to maybe ax plus c, something like that. Or maybe y equal to ax squared plus x plus c, could be like that. But what's happening in background right now, we do not want to care about that much because we say we want to be a users of AI. We don't want to go into the area of mathematics that should be worried by mathematicians. Yeah. So the system automatically gives us one algorithm. This algorithm, linear regression, is one of the many built-in algorithms given by Wolfram Mathematica. It say, hey, if you are trying to use this regression model, it say, I suggest you to use the algorithm called linear regression, and the system have defined for us. Now, after that, we say that this is something called my model. Yeah, I say, okay, fine. You already defined for me using method of linear regression to come out for this regression model. Now, after that, if I want to use it, same thing like mathematically, if you already can plot a curve to show a relationship between x and y, the next thing you ask, if I have x equal to 8, how much the value of y is? So you say, in this case, your y values be 7.19027. So you get a concept already. As long as you define the features or the independent variable versus dependent variable, the system will come out with a regression model, try to tell that what will be the y value is. But bear in mind, like I say, in reality is we are not dealing with just one x. We're dealing with xy, x2, x3, x4. Now, let's do something more aggressive, slightly more aggressive. Now, in this case, I'll share with you a second model called classification. Classification means that the output itself is not a numeric value. The output itself could be any discrete value. Discrete value in this case here, in this example, I used 3 different colors to represent. The output value on the right-hand side could be red color, blue color, or green color. So the feature itself, we have 2 parameters. The features on the left-hand side here, let's say we call it xy. We call xy as our features, and the output here is 3 different colors. So as simple as this thing is, we say, hey, with less than 30 set of data, I run it. Now, the system say, okay, now I take in your 30 set of data. Now, let's train it. Train means what? Train means I want the system to understand, help me to define what's the relationship between the features on the left-hand side and right-hand side. So now, I'm using this built-in AI function called classify. Immediately, the system say, okay, based on what you have defined, the 30 or 20 over record on top, the system automatically chooses one algorithm for me. This algorithm is a very popular algorithm used by machine learning practitioner, yeah, and the method it uses is called nearest neighbors. So automatically chosen for us. We do not have to do much. Let's say let the mathematician worry about that. Now, so after that, we say this model is ready for me to use. What if today I key in these 2 parameters down here? Now, let me put on top here a little bit. Yeah, I say 2 parameter means what? I have first parameter is 0.721 and 0.97. Second one is 0.3 and 0.8. Then I want the system to tell me what will be the probabilities like. Yeah, what does it mean? So the system is telling me that, oh, based on this, what we have learned on top, the 20 over records, if we give me a new set of features here with these 2 parameters, 0.721 and 0.97, quite likely it's green color. You say 77.33% of chance of probability is green color. On the other hand, you say that 77.3% of probability, this second one will fall in the region of blue color. So now you've already seen, in machine learning, we can use for regression or classifications. Classification means that we can ask system to guess something that either true or false, black or white, male or female, things like that. Or regression, we can use it to actually predict some numeric value as outcome. Now, let's do something more. In this case here, let's say we do something slightly more complicated. This is something like very easy and practical. If you have computers able to hold all the pictures, do your interest. In this case, my pictures interest is only 2 things. I want to teach my computer to understand by looking at pictures here. This one belongs to you day or night. Now, immediately you will expand out your imagination. Now, I do not want to have pictures differentiate between day or night. Can I ask the system to train based on something else? For instance, If I take photos of human faces, let them smile, ask them cry, ask them make angry face or funny face, could the system actually tell that what's emotion of a person? Yes, the concept is exactly the same. So it's just like showing the pictures, flashing the cards in front of baby, telling him or her to discern among not all the pictures, what does it represent? So immediately we showed on top of the pictures here, not many pictures altogether, you only have 30. You say, okay, these 30 pictures, right? The system automatically chose one method called logistic regressions to represent how it has learned from the data on top. So after that, we immediately can make use of this data. Let's say we throw in 3 new pictures. These 3 new pictures are not in the historical data. I simply take a website and put it here. I say, please tell me what you think. Yeah. So the system say, oh, okay, first picture, I think 99.6% is nighttime. And second one, I'm very sure is daytime. And third one, I'm also very sure is daytime. So this is night, day, day. So of course, it's for this thing is quite simple. When the picture is darker, yeah, the system understands to be like not daytime lah. When the picture actually whiter, it should be daytime. So it's not difficult for machine learning to learn something like that. But we can make it to be more sophisticated by putting in more historical data for it to learn something more interesting and useful. Now, let's take a closer look. Now, what are the things that it could possibly do? Now, in this case here, let's say I want to make it something more sophisticated. Now, in this, not just putting pictures on left-hand side, but on left-hand side, I use, I say, verbal description. Verbal description, you put in something like that, right? For instance, I say, hey, I have something called furry and warm. You refer to the cat. So this input, you can verbally type in, you can audibly speak to, or you can actually use a paragraph to describe it, or you can use some number to describe it. The system does not care. This is a beauty about machine learning. So it's so that if you put in any features that you think that making sense to you, the system will try to learn. Of course, whether it's accurate or not is another story. But the methodology becomes so much simple. The only thing you have to consider later, I'll share with you how you actually can tell this model is accurate enough for you to put into production. For instance, here, if I run this thing, my data, the system run through everything, say, hey, these are 4 outputs or classes I try to learn. And the method you have chosen for me automatically is called Markov. Yeah, the system for Markov is one of the methods actually used in classifications. Yeah, and in this case here, it believes that Markov is the most accurate. The system believes so. But of course, you could have a choice. Say, Peter, you have so much automation, it's wonderful. What if, as a researcher, I believe that I have some method actually far more accurate than this? Can I define my own? Yes, you could. Yeah, we have something called feature extraction. If you are not a stranger in the machine learning field, then you know what's feature extraction. It can allow you to define how you extract features, yeah, what to look into. But if you say you are ordinary people who want to get quick result, I'm not really a person who want to spend a lot of time in AI, but I'm told by my supervisor, my company, I want to achieve some result in a quicker way. Yes, like I say, ordinary data set, yeah, with fair amount of little bit skill and data analytics, you can achieve quite accurate output with technology like that. Now, in this case, if I put in 3 descriptions, say my pet smart and live fish and does not swim, the system will say quite likely this one is talking about cat. So the system also give prediction based on our audio or verbal input to tell that maybe which one you're talking about. Yeah, it might not be accurate all the time. Like I say, the samples data is very small, but the way it gives you output is very straightforward and very easy and fast. Now, another thing in machine learning, before I talk about clustering, there are many other methods. One of the things that many of us could be interested in will be about predicting the sequence of events. And in this case, it's very simple. Yeah, scissors, rock, paper. Yeah, if you actually have a sequence event like that, someone gives you a paper and rock. Then after that, it gives you scissors. After that, you look at this sequence event here. After rock, it comes out scissors again. So in the real world, right, a lot of time that we can observe there's a sequence of event happening with certain pattern. So if you visually inspect it or mathematically actually try to describe, quite likely you will see there's certain pattern. A person that knowingly or unknowingly, maybe after you show 2 times a Caesar, maybe my behavior, like I try to show paper, the third. But you can further analyze it. But in this machine learning, make it so simple. Even now with actually 4 pieces of data here, only show you 4 past events, how it happened. Immediately, actually, you can train it, ask the system to come up some sort of forecast what will happen next. Yeah, isn't it wonderful if you today that you have something that you observe in real world that happening as a sequence event. The next thing you say, if someone show me, same person, show me Rock and Caesar, what will be the next actually things it will show? The system say quite likely 42%. After you see Rock, Caesar, third one will be Rock again. Yeah, again, the question is this accurate? Could you put it into the field to test? Yes, this will be the important question, yeah, for us to decide. But what I'm saying is the technology, machine learning, just feel like code right now. It's not something that you have to crack your head, try to find out what kind of algorithm you use. In this process of the algorithms that make available to end user today, majority of part have been made automated already. That's why our hidden topic for today is automated machine learning. Automated machine learning. Of course, that how to make it further accurate, that involves several actually common sense and some of the skills in the AI. Now, let's look at some other typical applications. Like I say, I promise you I'll show you 4 applications, right? But these are some of the common applications people can put into use in the business world. Yeah. First one, like I say, if you're interested, you look at how you maintain your machines, yeah, and to predict whether machine will be in a good condition, people use a called predictive maintenance. And people like to use predict behavior of customer. People like to use a predict the pricing or forecast pricing. People want to predict how certain recipes will affect the qualities of certain engineer products they use it. But more than often, people use it predict also whether your customer will stay or leave. And what will be the next item we should recommend to our potential customer called predictive marketing. And predictive operation will be how we predict that will be our output of performance of certain machine or logistic systems or certain management system. And also we can predict the quality of certain things like the customer service all the way to certain product. And also we can predict like customer lifetime value. We not just predict that how we will respond now, but we can predict, like say, in the next 5 or 10 years to come, which customer will contribute how much money in figures to your organization or to your company. These are commonly used applications. Of course, these are not exhaustive. Yeah. And in our training class, in fact, we'll cover this all different 9 types of application plus some other typical case studies. Now, let's come to our first one, customer analytics. Now, when it comes to customer analytics, right, after I show this one, I will let you do the first exercise. How to this one do customer analytics in a very practical way. First thing is, we need, of course, import or train our based on historical data. Now, import here is very simple. This whole link here is a Google Sheet link. Now, this link is generated by Google Sheet. If you store whatever Excel file or CSV file, text file, in Google, you can always ask to publish. After you publish, right, you say, okay, I just want to import it inside this Wolfram Mathematica for machine learning. Now, in this case here, we have something is 3 column. Not to worry. This is to tell which particular rows or columns or worksheet I want to extract. So after extract, the first thing is you just import, then you ask the system to train. You see this whole thing. Let me run this one. I import first. Now, you say import. Now, let me import first. The data imported about 3,000 over records. Yeah, this involve a CSV file in the cloud stored in Google Drive. Yeah, after import, I say, now I'm going to train these 3,000 records so I can understand the behavior of my customer. So I do not have to explain what the behaviors we are talking about. The system will quickly run through all the available algorithm that built inside the backend. So after that, I say training completed. So now the system will choose one of the algorithms that it thinks can best represent our historical data. Now, next thing I say, after the system trained, doesn't mean actually it's accurate enough. Why not accurate? Because we dump in a lot of data. Common description is garbage in, garbage out. If you throw in the garbage data, the system might not be able to train very properly. But let's say assume that in this case, we have been putting in quite a nicely actually organized data. And the system show us here, the accuracy here could be as high as 80%. Yeah. So it say that based on the historical data that I have trained about 2,000 over records here, the next time you're going to do this model, right? You want to see that which one will be your VIP customer, quite likely the accuracy about 80%. Am I happy? Yes, I'll be very happy. Because if I'm going to ask one of my new hire to talk to all my available 3,000 or 2,000 customers, say, hey, please go there, give them a call. Please approach them, sell this thing. Yeah. If I ask new guy to between a few months to talk with 2,000 guy, he might eventually what happen? First 10 customer, it could be very, very exciting. After start talking about 50, 10, 100, 100 customer, he's going to get tired. He's going to get slowed down. He's going to get uninterested, quite likely to many people. So, but what so happened in a 101, the customer turned out to be a major VIP. Just because I'm tired, just because I thought that I'm less motivated, people hang up my call. I'm not very actually in a very happy tone or enthusiastic to promote to the customer. I might lose that VIP. So now, if I have an 80% accuracy of model, immediately the new hire in your company, you say, hey, if I put in this particular customer who is 47 years old with one child, who actually marriage status is married and living in Glen Valley, yes, can you tell me that should I actually talk to this customer? Whether you say yes or no. So immediately you say, oh, this customer quite likely 87% chance. Yes, might not be interested in your product. Then you can immediately skip this customer and go to the next one with the one who show higher chance of success. So not to save you time from talking to less potential customer, but it gives you higher success rate to be dealing with the right person in business. So now, is it Peter be talking about business? We all coming from academic majority of us. Yes, not hold on to the horses. Yeah, because usually we are easier to talk about figures. Next thing, our top engineering and productions. Yeah, you can use the same methodology to start imagining what you could do next. Actually, easily in your own R&D or in your own interest. Now, first thing here, what about predictive pricing? So now, same thing here, I'm going to import a housing price from Google Sheet. Now, this entire thing here, you see the step I'm doing right now is repeating itself. It say, hey, Peter, you seem to do the same thing over and over again. There's 3 steps, right? Import and train, accuracy check, then use a model. It's true. Yeah, like I'm trying to share with you that take away your fear. Yeah, if you have something you want to predict, something you want to actually forecast. Yeah, of course, there are many other methods. Mathematically, you can do forecasting. There are many other methods. You can come up with own linear, come up with regression model. But like I say, if you're not really a full-time programmers, you're not really mathematicians. You are just engineers. You are maybe from social science. You're from economics. You're people who are in the marketing, and you also people are doing like applied science, like chemistry and physics. You want to predict certain outcome, and we have a lot of data already. This will be very handy. So in this case here, if I again import this data and import is done, I just train accordingly. Let me give you one example that why you are in the R&D, you will sometimes find it very useful as well. Okay, you see. Let me double check if the data coming in is correct one. Yes, it's correct one. Okay, I need to truncate the header away. Yeah, I don't want a header. don't mind what I'm doing. I just want to make sure the system do not import a header, because I do not need the header for me to tell me what it is. The system simply can understand just like that. Yeah, just like that. So now the training, you see that can be completed actually between like less than 2 seconds. Yeah. Now after that, I do accuracy check. Say in this, based on this case, right? Can I know how much accurate it is? The system immediately show me a plot like this. Now, a plot like this is very important. It show me that whatever I predict, compare the realities, right? Now, the left-hand side here is when I say realities, this is actual value. This is actually how much people will pay for the particular property. And this is what system predict. So the system predict, in ideally speaking, it should be a straight line. Whatever it predicts should be the same as the actual value. But because it's prediction, the system going to have some more or less some error. So the system show that sometimes the error is bigger, sometimes smaller. Then it's up to you to decide whether you want to use this model or not, and to what extent you can use it. And you can actually have to start talking about level of confidence, you have to talk about standard deviation. But let's put that aside. Yeah, assuming that after looking at the accuracy level, I'm happy with that. Immediately you say, hey, what if I have a house with this number of sizes and with this particular location and these particular parameters, how much my potential customer will pay for? You say, oh, based on this one, right, what likely is going to pay for maybe about 37,000 USD for this particular unit or property. Yeah, with the standard deviation 3.744449,000. Does it make sense to you and I? Yes, it's up to you to further discern whether it's making sense or not. Now, I say, why does this important? Yeah, for instance, I was approached by someone recently. He said that I'm doing actually research on combustion engine. Yeah, to find out which kind of parameters design on combustion engine be giving me the maximum output, right? I need to come up with regression model. But the features or the independent variables actually have 5 or 6. Yeah, it's for me difficulty to come up with mathematical equations describe that. If I have 5, 6 different variables, but I have a lot of empirical data. That means laboratory data. Yeah, so could the system actually construct for me a model so that I can know with which kind of combination of parameter will actually fall in the region of optimizations. So this is the next thing I'm going to share with you. Now, in this case here, for instance, I have actually machine's behavior. This machine behavior means that based on the past data, right, I have among all the IoT or sensor data. Yeah, this is very common already. A lot of machine developer, they already have built in a machine learning actually module into the interface. So the system, they not just sell you machines. Yeah, because I just listened to a presentation by the machine maker in Malaysia about 6 months ago. They say all the machine they're making right now, you could have a choice to further add in some of the sensor if you want to. If not, they always build in some basic sensor already. And all these sensors in the past, right, you need to go through certain module, yeah, to exchange with the whatever your desktop data. Very difficult. But these days all built in. They you should have a Linux system that built in the system. They will collect all the data immediately from the IoT sensor. And also the next thing is they have machine learning that built in. So if you want to use a machine learning to do what? The first thing they usually immediate example is to predict or to tell you when's the next time you should service a machine already. Like your car lah. Every 5,000 kilometers usually or to 10,000 kilometers, you need to do an oil change. Yeah, but machine is not like that. No. Machine, if you say after 10,000 1 kilometer, I do all my oil change, when my car breaks down, or not really lah. Maybe it's not as smooth only lo. Maybe it'll be hurting my engine a little bit. But machine is not like that one. It's somehow before you service it and it breaks down. For us, our car breaks down, we need to spend time to fix it. But machine breaks down, it affects many other machines in the production floor. Because a lot of time this day, a machine itself is just one of processes. One process breaks down, maybe it affects entire supply chain. So in this case, people find it very important to do prediction about machine performance. Before something happens, I want to do it. In this case here, a simple actually data set can give me accuracy as high as 83% to predict whether my machine will continue to function or not continue to function in the next few hours or next few days to come. So in this case here, I can put in this particular actually sensor data to tell me that whether it will keep on going or not without actually breakdown. He said, okay, if we're going to continue now for next few hours or next few weeks or next few months to come, depending on a historical model, he said that 83% you are fine, you should carry on. Yeah, if you think 83% is something confident you can take, then you say, okay, I'm not going to do anything with the machine maintenance, at least for now. So now, the next thing here, when come the last model, I'm going to show you, then I need you to do some actual exercise during the break time very soon. It's about predictive engineering. Now, this predictive engineering, same thing here. I have a set of data coming from my laboratory data. Yes, this laboratory data, right, this is coming from, I store in my Google Sheet already. So the system actually get all the actual recipe, combination recipe, to come up with a concrete block that will give a high yield and high strength. Yeah. So in this case here, before actually I do that, there are some other, of course, mathematical analytics you need to do. And today, if you do machine learning, like I say, you do not have to be actually full-time coder. You do not have to be like a full-time mathematicians. But there are certain things like common sense, like doing data analytics, you still need to have, yeah, in order to use machine learning in a very effective way. For instance, one of the things is correlation. I want to find out among all the independent variables, which one matters the most to my dependent variable. Yeah. So in this case, for instance, right, the number, the strength, or number of the number of certain value I want to achieve in my outcome, which one will be the important determining feature. So the system tell me, oh, some of them are very important one. It's like, for instance, in this case, you say, if you look at 0.666606, you say the aggregation of the fine cement will be very important to determine whether how strong your concrete is. And the second one is the cost aggregation of a cement. It's not that actually important, only like 0.14 correlation. And some other thing is like the fourth one here, the amount of water, that means that the lesser water you have could be stronger your cement is negatively 0.39 correlating to the strength of the cement that will come out. And so on and so on, so on and so on. Yeah. So if so on and so forth, then you can decide among all my maybe 20 or 30 independent variables. Some are important, some are not important. Immediately at first hand, before I do machine learning, you know that what data you should collect with. So these are basic data analytics. The system can help you in advance already. After that, I say, okay, I'll take in all those actually parameters as they are to do a training. So I start training it. Very simple. System running through all the built-in algorithm, immediately stop in gradient boosted tree. You say, okay, the method you should use called gradient boosted tree. Let's see how accurate it is. The system show up here based on this output. This is, you draw a straight line. Again, this straight line is up to you to decide. Among all the dot here, are they close enough, yeah, between the actual and the prediction? If you think that all those actually dot, they are close enough to the ideal straight line here. You want to use a model? Yes, you can use a model. So let's say I'm happy with this model. Immediately I say, the next thing I want is I start using a model. So you see, I've been doing the same thing. Now, if I have the number of fine cement, coarse cement, water level, I want the system to tell me what will be the projected or forecasted strength. That will have the system say, the total strength you're going to get from this combination recipe is 33.6041 unit. Now, the next thing come to a very important one. By saying the person that approached me, say, Peter, having problem to model my laboratory data. So now, In this case, if you want to model a come up with a model with laboratory data, like let's say the combustion engine, right? In this case, here, I only play with 2 parameters. I say, now I went down with machine learning model. Next thing, I want to adjust my number of cement. Yeah. If I increase number of cement, 5 cement, this is how my actually concrete strength will change. I can start doing the simulation already. Same thing, if I play with water, right? If I increase my water level, the more water it is, actually less stronger the cement become. If I make it lesser, if I say somehow I want to stay water in this level, I want to actually increase my cement level to here. So you see, sometimes you go 50, 53, 57, 58, 61, so you go all the way to 70, 80, 90. It seems to actually having a linear relationship. But sometimes you put more actually different parameters, some might not have. So you start asking yourself, is there actually a region optimizations we could have? I can visualize it. So in this case, you can use a normal techniques that called contour plot. I want to see with these 2 parameters, yeah, cement and water, is there a certain region that with the right combination cement water give me a highest number of strength? So immediately it showed to me here, it seemed to have this relationship. Yeah, I can move this thing, my mouse across from 60 to 50 all the way to 40, 30, 20, 10. So if I move to this region, it seems to like if I have enough level of this here is water level, and this is the cement level. Anything I fall in this region here, I should achieve my optimum 80. So in this case, I can somehow find a combination is less cement, but also less water. The lesser cement you have, of course, the cheaper the cost is. With lesser cement in this region here, and with certain amount of water, I still can achieve the same strength that I want to achieve with higher number of cement. So we can find this region where you should go. I think cement is from between 500 to 500. Yes, this is level of cement. From 500 to 550, right? Yeah. And in this case here, if I can even stay at 500, but with certain control amount of water, right? I can achieve the same result here compared to higher cement with less water in this part. Yeah. So this is certain things that can help you do customizations already. Now it's 11 o'clock. I'd like you to do exercise now on your own. I'm not going to ask you to do a lot of typing. Easiest way how to do, easiest way. Now let me see how I can go back to yes, this sandbox. Let me open up sandbox with one little exercise. Now, in the sandbox here, what I need you to do is on your own here, right? The help file is always very handy. Yeah, because machine learning, unlike some other actually workshop we had previously, you can easily type out something in a very quick manner to test on your own. Yeah, but machine learning, it involves several actually specific code that you need to actually use before you get right. It's simple, but during a short training like that, sometimes follow screen at the same time is not that simple. So the easier ways is under this help. Yeah, you click on documentation. If you're using desktop version, same thing. Help documentation. You will pull out the help file and the tutorial accordingly. So what I want you ask you to do is you go there, yeah, click on the help file. In the desktop version, right, this thing will pop up in front of you. But in the cloud version, you show on the right-hand side. These are among all the areas of tutorial and application and documentations available for you. Now, if you slowly scroll down here, you see here there are some other things like fast introduction, archive and repositories, Wolfram language products, Wolfram University, that means they build in a lot of tutorials and video for you, developer resources, and we see this term means that actually you can develop your own application. Yeah. Now, many of you are asking, hey, Peter, I find wonderful. What should we actually go on? Should I actually immediately purchase the technology? Yes, if you need your university, many of you in Malaysia, right? You already have licenses available on the campus. If you do not have, or you're coming from private sector, there are 2 ways you can try. Yeah. First thing is, of course, you can always go for the free version, training version given by us. We will buy complimentary, give you 1 month, no issue. Yeah, you can play with that. Second thing is you play with the sandbox. Third thing is, yes, some of you may say, hey, I want to try it for education purpose. For those commercial users, you can try with Raspberry Pi. Yeah, this is not hidden secret. Yeah, Raspberry Pi that you can go inside. There's a training version available. You can use it for training or use it for own training, and also that you can go to this developer resources. Try out with some free resources. Now, Wolfram is transforming from a fully paid proprietary software now somewhere between to open source, open communities, open resources. So you can find a place that you actually can start somewhere for your training and learning. But of course, that you say, Peter, I want to go even further than this. Please do speak with us. We'll point you to the right direction, the most economical way. Now, I'd like you now move back here on top. Yeah, look for something called machine learning. This one, machine learning. You go inside here. Machine learning here. Now you see here, first one called machine learning overviews. We also have deep learning, neural networks. We have feature detection. Like I say, today we are not explaining this part, but if you are coming from the domain expertise of AI, this is not something unusual, but you find it is very useful and important. Is that computer vision, text analysis, so on and so forth. I'd like you to click on machine learning overview first. Now, inside machine learning overview, it shares with you some of the very important super function that built in. Now, the super function we have been using so far in my workshop just now, example, I share with you classify, predict, yeah. I also share with you how to do sequence predict, yeah. There are some other thing is it allows you to build your own classifier and predictor function, yeah. And so, some other things how to do accuracy measurements. There are some other methods like for nearest, fine fit, non-linear model fit. Those things is up to you to explore. So the only thing right now I like you to play with during a break time, we're going to have 10 minutes break, by clicking on this classify. Yeah, this classify, once you go inside, it will, you further scroll down, it explains to you how it works. I'd like you to come here with basic example. Now, this basic example, this is how it works. In order for you to actually have a feel how it works, yeah, basic example here, if you're using cloud version, if you move your mouse here, you simply click once, you say copy, yeah, copy already. So then you move to the left-hand side here, same thing, Control V, you paste it down here. Then what you will have to do is evaluate cell, start running. The next thing is you copy again, then again put it here, Control V, paste here, then evaluate cell again. The system start running. Yeah? Start running what? Start doing training. The training only based on 1, 2, 3, 4. 4 records only. And the system say this is a logistic regression. Number of training example 4. And the next thing I want to use it, same thing, I come here, copy again one more time. I paste it here. I want to predict 2.6, or I want to change something else. I want to do 2.6, I say 3.2. Same thing, shift enter. The system say it's going to believe if you have an input 3.2, your output is supposed to be B. Now, there are several other actually examples here, how to show probabilities, classify multi-example. I'd like you to go through at least the first example. Yeah, you sit down here. There are some other things, for instance, application is slightly more advanced. This one, you click on application. You can also copy the whole thing. This one is trying to actually learn on handwriting. For instance, you can put in a lot of handwritings here with different handwriting. The system try to learn. Now, you say, hey, this one looks like child's play. What's so good about this? Trust me, a lot of fantastic projects come from a very basic algorithm if it works well. Yeah, this very small example will work very well in commercial use when it comes to written recognition. Why written recognition is so important? For instance, I was approached by one of my business partners. He said, Peter, can you help me develop a system every time when someone walk to the security post by handwriting something, yeah? Can you auto, when we take a photo, can you auto actually discern what's the number? So it will auto record into my security system. Or another way, very popular one, is already available in market. If my camera can take a photo of the license plate, can the system auto recognize it, convert it into a numeric value into my database? So I know what cars come in. This already in a highway speed trap. Yeah, I take a photo, you think someone sitting behind try to look at the photo of plate and key in. No. Mostly is machine learning already. Take a photo, you know where to look for a license plate, and you know what's the number. That's why police does not like you to have simply very creative license plate, even warna-warni car license plate, because in the past that they find it difficult for human eye to differentiate. But now they know they have machine learning, their AI. If you're too very creative, this license plate, you'll also get confused the system sometimes. But a very good AI that has learned enough, the system able to tell what the number is. But starting from this simple algorithm. So now it's 11:11 right now. So we will take a quick break and you play through with this. We come back by 11:25 lah, 11:25. I'll see you 11:25. Then we go on with some very interesting case study, and you see that how this thing can help us move on for betterments in our life. Yeah, I see you in 11:25. If you have any questions, I'll stay on the chat room. I'm ready to answer any question you may have. Yeah, thank you. I see you later.
Tick-tock on the clock, but the party don't stop, no. Don't stop, make it pop. DJ, blow my speakers up tonight. I'ma fight till we see the sunlight. Tick-tock on the clock, but the party don't stop, no. You build me up, you break me down. My heart, it pounds, yeah, you got me. With my hands up, put your hands up, put your hands up. You build me up, you break me down. My heart, it pounds, yeah, you got me. With my hands up, put your hands up, put your hands up.
对呀，我还在办年货嘞，刚买了2挂粉，剩下黄梨饼和鸡泡。
DJ, blow my speakers up tonight. I'ma fight till we see the sunlight. Tick-tock on the clock, but the party don't stop, no. Don't stop, make it pop. DJ, blow my speakers up tonight. I'ma fight till we see the sunlight. Tick-tock on the clock, but the party don't stop, no. You build me up, you break me down. My heart, it pounds, yeah, you got me. With my hands up, put your hands up, put your hands up. I'm waking up to ash and dust. I wipe my brow and I sweat my wrist. I'm breathing in the chemicals. I'm breaking in, shaping up, then checking out on the prison bus. This is it, the apocalypse. Oh, I'm waking up. I feel it in my bones enough to make my systems blow. Welcome to the new age, to the new age. Welcome to the new age, to the new age. Whoa. solution, I suppose. We'll paint it red to fit it right in. Whoa. I'm breaking in, shaping up, then checking out on the prison bus. This is it, the apocalypse. Whoa. I'm breaking in, shaping up, then checking out on the prison bus. This is it, the apocalypse. Whoa. I'm waking up, I feel it in my bones enough to make my systems blow. Welcome to the new age, to the new age. Welcome to the new age, to the new age. Whoa, whoa, I'm radioactive, radioactive. Whoa, whoa, I'm radioactive, radioactive.
That afro black boy with the gold teeth. He dark skinned looking at me like he know me. I wonder if he got the G or the B. Let me find out and see. He coming over to me, yeah. These days I'm way too lonely. I'm missing out, I know. These days I'm way too alone, and I'm known for giving love away, but I want someone to love me. I need someone who needs me. 'Cause it don't feel right when it's late at night and it stress me in my dreams. So I want someone to love. That's what I fucking want. You know it's harder to find in these times, but I got nothing but love on my mind. I need a baby while I'm in my prime. Need an adversary to my down and weary. These days I'm way too lonely. I'm missing out, I know. These days I'm way too alone, and I'm known for giving love away, but I want someone to love me. I need someone who needs me. 'Cause it don't feel right when it's late at night and it stress me in my dreams. So I want someone to love. That's what I fucking want.
If I could go back to the day we met, I probably would just stay in bed. You run your mouth all over town, but this one goes out to the sound of breaking glass on my Range Rover. Pay me back, oh bitch, it's over. All the presents I would send, fuck my friends behind my shoulder. Next time I'ma stay asleep. I pray the Lord my soul to keep. And you got me thinking lately, bitch, you're crazy, and nothing's ever good enough. I'm so beyond those that don't make me fall so fucking done with you, girl. So fucking done with all the games you play. I ain't no tic-tac-toe. Send the X and O's on another note. I'm don't make me fall so fucking done with you, baby. So send the X and O's.
Please insert your parking ticket.
Okay, we will come back in 2 minutes time, then get ready. Okay, let's get the second part. That's getting more and more exciting. And again, my apologies for some of the songs we played just now. That's why now leave your kid go on internet unsupervised. So we randomly chose some song, didn't turn out to be very appropriate just now. Okay, our apologies here. Okay, come back here again. So AI machine learning impact here. Now, again, these are some of the latest survey about 2 years ago, again by Forbes Business. And what Forbes Business says that compared to those actually who use AI and don't use AI, what will be the major difference in the bottom line? Now, if those actually use AI, right, in organization, according to your research did about 2 years ago, they say they realized that company will actually experience 21% faster to the market. Yeah, faster to the market means that when you roll out a new marketing campaign, when you roll up a new service offer, when you come out with new products actually or development, with the AI actually implement one way or another in the process, usually they have 21% faster compared to their competitors. Yeah. And also overall, they will see that they will enjoy 40% improvement in their productivity in a general way. So they also have seen that because they could get faster and beat their competitors in the market, they actually increase the output, also the throughput in the entire process. Of course, in this whole improvement of the output on throughput, the total unit cost, especially overhead cost per unit, will be automatically reduced as well. So they observe as much as 28% of reduction in the operating cost could be realized by certain organizations. And also they see, even though between same companies, certain departments adapt to the use of technology or machine learning, compared to departments, they do not use any machine learning or AI. They are significantly different from 2 times to even 3 times. Internally 2 times, externally there could be 3 times actually better than their counterparts in the market. This is how the reality is. Let me give you some example. If we have something like this, now this is for fun. Like say AI machine learning can use in many ways. So let's say we have 3 features. 3 features means that you look at the age of the person, look at the gender of the person, look at the emotion or sentiment of the person, and you look at like man with older age, man with the lesser older age, and also of a girl with a little age, with different actually sentiment. So now, if we actually, based on these 3 historical input, could we actually predict the gentleman right hand side to check what the gender is, how old he is, what emotion? Say, Peter, what's a big deal about this? Now, like I say, a lot of major production application that impact our daily life come from very small actually theory and proven algorithm, then we can roll on. So if we can actually do this with the left-hand side historical data to predict what outcome on the right-hand side, then we can easily say we're going to predict the sentiment of all the people in these actually pictures here. So if you can see not just about 20 people on the pictures right-hand side, but 2,000 people on the right-hand side, then it immediately can start actually thinking. If the system can look at the facial expression of the person to guess whether he's happy or upset, can we actually, in a way, based on the audio or the verbal word they use, either in written form, in the audio form, can we tell whether they are happy customer? Because this is really important. Companies spend billions of dollars to advertising company and survey company to find out how people think about the product and services throughout the year. This is how much $1 billion investment. I do not have an exact figure, but all companies need to know how they're performing so they can adjust marketing campaign from time to time. But AI make that available. How does it work? How does it work? Let me show you one example. Then later on, I'm going to go on to show you exactly how it actually goes into operation. Now, this is one of the successful case study we had about 3 years ago. Like I say, if you can discern from an image as an input, you can actually use the input in many different forms. In this case, they're using a written form. So we have a company about we have a client about 8 to 10 staff. They're working 10 hours, 7 days per week. What they are doing every day is they're reading 600 news clips per day. 600 news clips coming from newspaper, English, Malay, Chinese, Tamil, or magazine, averaging 600. This is how amount of stuff can handle a day. So after that, they say, I'm going to give a rating. It's a negative or positive. For instance, if today government roll up a new chip policy, for instance, if government were to say 2024, we're going to have GST, immediately everyone complain about GST. So what they are doing is they take newspaper, magazine, even from the news feed from radio, also from television, but in this case, they focus on the written form. They say, what people, when they talk about the keyword GST, are they using the word generally more to the negative tone or positive tone? So government will subscribe to the service, want to know between this week, the moment I announce 2024, GST will come to place already, how Rakyat will think. So that they will actually go through this, but the whole process is expensive because you're going to hire people 10 hours per day sitting there reading newspaper. slow, also subjective. If today I gargle my wife before I come to work, then maybe no matter what people say on newspaper about good, happy, to me maybe it's less happy. It's very subjective. So now what we did is they engage us, say, Peter, if I give you all those paragraphs and text, could you help me automatically tell me what would be the positive or negative sentiment for each actually news? We say can, because it's already built in. These are not rocket science already. So we take in that all the whatever text form, the system will automatically running 24 hours and 7 days. This no longer actually limited with 600, 700 newspaper. So they can actually take in as many source of text they want. They can convert it from audio to text. Google already can do that. Yeah, you subscribe to subscription of Google, they can convert audio to text. Google also can extract audio out of video, convert the text. They also can actually convert whatever text they see in video into text. So with all the different sources of text, we can immediately, between seconds, to give you a result, what people think about GST. So this is about how powerful it is. So now I share with you now how we can actually do this thing in an easy way using this technology, what we have on the desktop, on the cloud. But before we go on, like I say, today I share with you when it comes to machine learning, they are very important three aspects. First one is regression. Second one is classification. Third one is clustering. Clustering means that you will, before actually we can tell whether your set of data belongs to A or B or C or D, whether it's 1 or 2 or 3 or 4 in rating. If I throw in a bunch of data without this kind of label or rating, could you actually help me do some sort of labeling automatically? It's called clustering or grouping of data. So this is very important, grouping of data. Grouping of data is now simple. For instance, if you look at an income person, you say, oh, high income, low income, poverty, things like that. But if you further put into gender, you say, oh, female population, yeah, rich, middle, poor. Man, rich, middle, poor. If you further add in age, you say, oh, middle-aged man, rich, middle, poor. Or old-aged woman, rich, middle, poor. And then later on you say, oh, I'm not just add in gender, age. I want to add in ethics. Whether this is actually Malay, Thailand, people from Thailand, people from China, people from Indonesia, I can further add in about maybe which area they are living in. They are living in Subang Jaya, they're living in Kuantan. We can add in all this kind of thing further and further. So the grouping become more and more complicated until one hand we say we cannot find out a pattern anymore visually. Using normal data mining also difficult. So in this case here, clustering becomes very important technique. For instance, here I have actually data here represent XY. Say this XY, could the system actually automatically help me to break into different classes or different categories or different cluster? So very simple one with one simple actually super function. The system immediately between seconds, it helps us break into 3 different clusters for us. So we're not too sure how it works actually visually, but behind actually a whole set of mathematics algorithm is actually just kicked into place. So what is shown here is, oh, am I sharing the right screen? Let me see. I'm sorry, I'm sharing the wrong screen. Let me move it back here. Now, this will be supposed screen. Yeah, now, in this case here, if I have data here is like this, yeah, my data actually, this whole set data in XY. So the system, I use a super function called find cluster, yeah, find cluster. It automatically actually help me to locate. There are 3 clusters of data that we can actually group them very differently. So again, if you put it into spread out in the white paper, then you can see this XY, the way actually it's scattered around, making a lot of sense. Certain XY fall into certain regions, certain XY fall in this region, very simple. But like I said just now, if you actually put in more and more actually independent variables, it's not that easy. yeah, for us to further break down which actually particular group of data should belong to certain class. But with this super function, then we can easily actually at any time we ask the system to do all the hard work. For instance, in this case here, the system say based on my previous actually analysis, there are 3 classes, so 3 clusters it can come out. So immediately, if I throw in any XY value, the system going to give it to me. Oh, if I have 3.2 and minus 4.6, it say this one should be following 99.8% chances it belongs to cluster number 1. So then you say, Peter, how does it matter? Yes, I know you explained if I put in age, gender, the area you're from, and your ethnic group, and also your income, things like that, you can actually automatically cluster for it. But let me show one example how actually it works in reality. Now, if I have a factory, yeah, I have about nearly 10,000 records with 4 variables here. These 10,000 records here, right, is a lot of data here. Using human eyes, right, you cannot really tell whether actually inside there they have different cluster. Why actually in production floor, sometimes the tell whether have different clusters hidden inside are important, because it means that for this particular data set, we can actually use different model to model it more accurately. Now, very quickly here, I perform a data transformation. You say, what does it mean data transformation? Not to worry, because every time that when we want the system to do something for us, we have to make sure the data comply to certain format. So that's why I just did. So the next step here is one line. I say, how find me the cluster. Cluster means among these 10,000 of all production data, I say, could I actually ask the system to find me? There are certain distinctive patterns. For example, there are certain time the factory actually goes better with certain combination of parameters. Certain time the factory not doing that well with certain set of parameters. I want to know what are these set of parameters are. So immediately I use clustering. So I can ask the system to show it to me. Oh, inside these particular factories, right? I could see actually the data set can be fall into 2 types of conditions. There are certain times, right? Output the factory actually is like that one. Certain time output factory is go something like very in normal shape like this, like bell curve, like this. So then I could see here, the factory is not actually as stable as I think. Yeah. At certain time of the year, sometimes the factory actually the output's like that. Sometimes the year is like that. Yeah. But if you put this thing in a normal analysis Excel spreadsheet, it's not going to see this. Yeah. This can only be seen when you use a clustering techniques to do this. And Wolfram have a series of built-in clustering techniques, yeah, algorithm built-in, which is automatically chosen for us in this case to come out analysis like that. So then immediately we know, oh, maybe we use certain machine learning to predict this part of performance and predict this part of performance. This is particularly true in this case. And my assumption is this factory is in the area with 4 seasons. At certain times, winter times and summer time, because the ambient temperature does change, it affects some of the engine works and also some of the heat exchange, things like that. So the performance of the entire factory also get actually slightly affected. So it becomes certain different patterns. So if you have different patterns, you need to use different model and do prediction to make more accurate. So clustering can play in many areas. Like for instance, in this case, another example, if I have a class section actually pictures like this is common. If you want to analyze the materials or you want to analyze satellite image with different colors. For instance, we have seen one very interesting example in the open community of Wolfram. They took hundreds of pictures of certain town. They want to find how many actually houses got swimming pool one. The one got swimming pool usually color show us some light blue, dark blue, certain different color, certain shape. So they want the system automatically look at this picture to calculate how many houses got swimming pool. Can it be done? Yes, they already did that. So using the same technique, there's something called clustering components. So the system able to break down these pictures based on different colors. So what we have to do is we ask the system break down to 5 colors. So we say this is cross-section pictures from material. We want to break into 5 different colors. So system start processing it. It say, okay, among these pictures, we have a resolution one. So able to break down all the color that actually close one another to only 5 types. Because in this original resolution, if you expand it, right, inside there contains of millions of dot matrix. And these dot matrix can consist of maybe hundreds of different colors. Your human eyes maybe can differentiate maybe 20 different colors, but in actually computer coding, each dot matrix represents a very unique color. In this picture here, it could be up to 100 or 200 different colors. So we ask the system to say, those actually the dot matrix closer to one another in colors, put it the same together. But in this case, I specifically wanted to make only 5 type of colors using clustering technique. Those are close to one another, they are put together as one. So after running it, I say, hey, can you show to me if I make the 5 colors, how does it look like? So the system say, okay, those are closer together, I make it to be 1 color. So in this photo here, you only see 5 colors only. So after that, you say, what's the use? Immediately, again, we can make use some of the available simple, actually, a function inside from which is mathematically used a lot like this bar chart. So immediately tell, oh, actually there are 5 type of colors. This is how we differentiate one another in terms of volume. So this dark blue, we only have maybe about nearly 70,000 dot matrix. And this one, the dark green, we have nearly about 240,000 dot matrix inside. So we can quickly conclude or convert the percentage. In this cross section here, which material, these 5 type materials, right? Each one of them compose how many percent. So same thing for a satellite image, you can easily tell how many percent of them they are waters or they are land or they are forest using different color to differentiate it. So the use of this kind of clustering is very wide. Now, another way is, for instance, if you are somehow taking photo, this is, I've been asked many times already by university, if they take 1,000, 10,000 photos, something, each photo represents something, each have their represent certain value. This one is randomly, we take somewhere randomly. So we say, could we actually learn from here? Then I want to tell the system quickly actually run through the training, they use predict. I say, can you now predict these 3 different types? Now, these 3 different types of shape, you see it's not from top here. Nothing. You check these 3 different shapes, they are not from top. We just say that based on what you have here, please predict these 3 will give what kind of value. This thing, like I say, it could mean anything in a reality. So you can take 10,000 photos, something, then you say, now I give you 3 new photos. Tell me what value it is. The system say, based on what I learned from top, if photo this shape, it is represent value 30. So immediately you can think already. In reality, actually have a lot of things can be actually best represented in image, but it could return certain value that I want. It will actually means a lot of research use already or production use already. Now, talking so much of machine learning, then you say, Peter, you say AI, one of the latest development is deep learning. Deep learning is using multiple layers of neural networks. It requires slightly more programming, but Wolfram have given you a stack of ready-made tools. You can create multiple layers. When I say multiple layers, it means that I throw in you one of the input. I do not really have to tell you that what should you do with that. The system will actually can pretty much auto-digest all the big data and improve the accuracy automatically over the time. Say, it could be so magical. Yes, I'll show you one example here. Just now I say, if today that I can tell the group sentiment, that would be very wonderful. But the whole things about how I can tell a person is upset or happy or not, we already have some sort of neural network, deep learning algorithm developed and put into repository. And all those things become just like a mathematical function. You can take out from a drawer and use it immediately. For instance, in this case here, I simply take in one photo from the internet. Then I say, can you help me to find where the faces are? So the system very quickly can truncate all the faces on this photo. Let's 7 people here. Automatically, this is part of the AI also. They know where to look for faces. They know something else are not human faces, something are human faces. Automatically trim up. Yeah, this is very common. It's not rocket science already. In any surveillance camera, right, you can actually very quickly put in the square to look for human face. Yeah, but the next thing is not a simple one. Is this built-in algorithm? They already built in. You don't need to train it. They already pre-trained about it. Of course, it's not 100% accurate because it's not trained for Asian face, yeah, unfortunately. So sometimes might not be that accurate. So now you can use your own Asian faces, maybe 10 or 1,000 faces, to train it to adapt to our Asians actual culture. So in this case here, now, very quickly, I say, can you please tell me what the age and gender and the emotion is? The system now will go to the cloud repository, yeah, the cloud repository keep all the algorithm. Now, immediately, as based on what's been trained, now it gives it to us that estimated age. You say, this is 2, I ask them to give me 2 probability. So you say that this woman, maybe 3% is 46 years old. And not 3% is 32 years old. You say, hey, 3%, where the rest of 94%. The system actually have many different output with different percentage. But I say a high percentage maybe is 46 years old, 32 years old. The system not very sure. It's not very sure. Yeah, because it's trained to understand this masala face. So Asian face, but what at least you know is female. At least you know it's happy. So if we scroll down here, you look at the gender and the sentiment, it's quite accurate, Only thing the age is not that well tuned yet. But now, the advantage of the deep learning is it can be performed out of core computation. When you say out of core computation, right, I give you one example. What does mean out of core? Now, this is something that I want you to play with right now. I'm going to copy this part of code. I put it in the chat room. You can, when I put in the chat room, right, you can actually go to the sandbox and try it. Now, I paste it in the chat room already. Now, you can copy the one in chat room. Let me share with you my sandbox, or so that those actually haven't got Wolfram open up, you can actually go along with me to the sandbox together. Let me open up sandbox. Yeah, here. Let me come back to here. Now, this sandbox. Now, you will see you did some of the exercise on the documentation, but now I'd like you to paste on this particular code. Yeah, this code called training data 100 equal the resource data, resource object CIFAR 100 training data. What does it mean here? I'm showing to you right now is you can actually not just upload your AI algorithm to a public cloud, a private cloud. You also can actually upload all your actually production or historical data to a private cloud or public cloud of Wolfram. Public cloud means that you need to pay for subscription of Wolfram data. They can store the size of data up to the level of subscription they have. If you want to have some actually private control, you can set up your own private cloud, either in your local network or somewhere you can share across a different site with faster speed and more secure. But keep that IT thing aside. If I actually access to my private cloud for data, this private cloud actually stored in public cloud Wolfram. It contains nearly about 50,000 of images with 100 different types of objects. CIFAR 100 means that 100 different types of objects. So if you run this one, the system is going to give you an output. Yeah. Let me run one more time. It's going to give you an output of 50,000 images, I think, with 100 different types. Let's see what will come up. Now, immediately it came out here, it showed like 4, 9 something, right? It means together here, you see all the images here. First one is apple, apple, apple. It show about, I think about nearly few hundreds of them. They belong to pictures of different angles of apple. So the system try to understand how does apple look like. Yeah, but it had 100 objects. So if you had actually private cloud set up like this, we can always ask the system to train this accordingly. Let me come back to my desktop. Now, you can use the sandbox version to download that, set the data 50,000 images. But the next thing is also this one's the code slightly longer. Like I say, neural network is very powerful. It can perform something out of core. Out of core means what? I'll explain that later. So, but the programming will be slightly not that straightforward compared to machine learning. Yeah. So now again, I copy this whole thing. I put in the chat room. You can go back to your sandbox and paste it to run this also. And now, in order for the purpose of illustration, I will actually run it right now. Let me switch the screen back to here, to my desktop version. Now, I'm coming back to here now. I'm going to run this entire code. This entire code actually asks the system to train based on the data I downloaded from this repository. So altogether, I say 100 different types of objects. Very quickly, the system done. So I say the coding is slightly tricky, but if you actually go through a class with us on deep learning, these are things are considered very kindergarten level already. Yeah, like I say, it has very powerful application, but coding requires slightly more. The next thing you'll be happy, but the next thing here, you are not able to run it on sandbox because whenever come to image processing, we usually want to use graphic processor to run because graphic processors it can run multiple threads concurrently. That means it can run many computations in parallel. So the very typical, my graphic card maybe have 64 cores maybe. So I can run 64 computation in parallel. So my entire speed, right, sometimes will be nearly 50 times or maybe 70 times faster compared I run CPU. So if I put it like this, I say my target device is GPU is going to pick up my DVI card on my laptop and run it in a very fast manner, at least in this case, 20 times faster than my CPU in my example here, 20 times. So the whole process of running here will take less than 1 minute. It's running on my GPU, DVI card, very efficiently. Now, if some of you are familiar with GPU processing, especially like CUDA coding, those are actually use GPU for computation, especially involve like gaming industry, or you involve handle a lot of vectors and matrices. Yeah. GPU is very efficient, but to do CUDA programming is very complicated. Yeah, it requires a very experienced coder to do it very efficiently. So sometimes to set up image processing or image-related machine learning, using DVI card is not that straightforward. But in Wolfram, actually just one little thing here. You say target device. As long as your GPU is DVI card compatible with Wolfram version, immediately no additional setting up needed. It's immediately make use of graphic card very efficiently, and train calling is done. See, now, once it's done, next thing I can start using model. I put in this Apple. Firstly, Apple is where Apple. Last one actually is product name. I try to test whether the system is full or not. I say, can you tell me these four things, what they are? They say, hey, quite likely, first one, this is going to be sweet pepper. Looks like sweet pepper. They say 67% chance sweet pepper. Second one, go up with this, like Apple. Third one, Apple. Also, 67% chance. First one, quite funny. They tried, it tell this not Apple, this telephone, 52%. For some reason, I think among the 50,000 images here, they able to pick up some Apples, the one being beaten off as Taiwan, turned out to be like telephone. So now, if you look at typical example here, able to do neural network computation in GPU makes a lot of sense. I tested this one, I ran overnight my CPU, these 50,000 images, it took nearly 11 hours now, CPU. But the GPU you see just now, it took less than about 1 minute, finish. Yeah, it's a huge difference if you want to run neural network deep learning, if you want to deal with big data, the system must be able to perform not just on DVI card or GPU card, but need to be out of core. Out of core means what? Out of core, compared to machine learning, right? Those actually maybe has experienced machine learning before. Every time you have new set of data coming in, you need to train it all over again. Yeah, you need to train all over again. I repeat now. If you need to set a new data like 50,000, 500,000 data, to say, oh, this week I received another 10,000. Could I train at 10,000 without training the previous 50,000? No, cannot. Yeah, at 50,000 with 10,000 makes 60,000. We train again. But using neural network is different. You can perform out-call. Out-call means that whenever I train the past, right? For instance, based on previously we trained the 50,000 images, the system first one cannot recognize the picture. It thought it's telephone. Quite funny. Say, how come you not know this is bus? Because I say, inside the images, they do not have something called blue color, like this kind of shape. Right? They still say, hey, this one looks like a phone to me. Say a phone. Second one, quite obvious. You say, oh, this one is a bus. Yeah, it's a bus. Yeah, bus, 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 bus. So it recognizes actually the remaining four correctly. I say now, okay, if you do not recognize a bus, right, can I add in this one? I say, now I'm going to train again. I'm not going to retrain again 50,000 images. I say I only train this thing. Whenever I see shape like this, right, this is a bus. This is a bus. This is also a bus. Yeah. So I want to use GPU to train it. So I do not have to retrain the 50,000 previous images. Only at least 3 images specifically tell the system these 3 things are bus. Do not be confused. These are also bus. Yeah. So after that, I ask the system rerun again. Now it's very clear. Whenever you see this thing again, this bus. It's our call. So neural network deep learning is able to handle actually big data in a very efficient way. So now, nothing is to close today's workshop. This last thing I showed with you. This is also another actually repository uploaded, not the data, but it's a pre-trained model. This pre-trained model is to train on many pictures people took in the internet or Instagram with tag location. So now it's called GeoTag data. So I said, I want to get this neural network deep learning algorithm from a public repository. Yeah, I can get it. Someone already did that. Yeah, I take it down. So if you did something, for instance, you develop something, you want to share with colleagues, you share with actually your friends or any user in the world, you can actually put this API in the application. They will get this actually algorithm down. Get an algorithm down from the website called MyPlace, yeah, immediately can put into production already. Now, if you put this MyPlace, right, somehow I take the pictures of this KL Tower. I say, can you tell me where this place is? By looking up the algorithm, neural network algorithm I put up there, immediately the system detect. It say, seems like there are 5 pictures I detected, very similar to this KL Tower that you took. And you also give me the tag GPS location. So I say, now, okay, if you can find this GPS location, can you tell me where location is? Wolfram many built-in many knowledge-based engine. So like what Desmond showed to you 2 days ago, this is part of the knowledge-based engine. By keying in the GPS coordinate, I can tag it right away. The system show something looks like KL Tower can be found actually in 5 places of the world. Yeah. First thing, of course, it detected correctly is somewhere in KL. Yeah, I get it correctly. And now 3-1, it found it somewhere in China, 1 in North America. I believe this one is Seattle, so that one looks like quite similar to KL Tower. So this is something that we can do very effectively with Wolfram actually make ready AI that, like say, in a very practical and very importantly, economical way. So now, in a quick conclusion, what could we do with that? If say, hey, this will sound quite interesting, it's something that what we want, but Peter say this is very practical and economical. What we are actually making this available to the commercial and R&D academic, we are doing 3C. First thing is crash course. Crash course will range from 5 days to 8 days, depending what you want to achieve. Even for academic world, I believe that you have more resources available compared to private sector. So usually 5 days, those who went through with us, you know that 5 days is more than kind of crash course manner, 4 days per day, we guide you. Instead of you going through the YouTube or something that you self-taught, yes, you can do that, But if a group people learning together with all the case study, at least 15 case study, you will have overview of how you could achieve it very easily in practical way by using machine learning to get some real result. So this is a crash course we offer. Second one is project-based coaching. So some people say, hey, yes, Peter, these 5 days or 8 days I attend, but my one not that much related to the marketing you're talking about. My one is more like engineering. Could you actually look at our cases? We are more actually interested in getting engineering related machine learning. For instance, one of them are asking us, I have collected many samples from different places of honey quality. Can I actually ask machine learning differentiate which type of honey is produced by which bees? Very simple solution these days, but we can give them coaching. Oh, so simple. Then some of them say, hey, after you coach it already, I know how to prepare data. I know how to collect. I also know how to deploy, but I have different sensor here and there. Can we actually help us design system to get this thing ready? For instance, the one I shared with you just now, the sentiment analysis automatically perform all the new script every day. This is something what we did. So these are a couple of things that we could do. But about crash course, what we're offering right now, the good news, only 250 ringgit. In the commercial world, right, this price tag can easily 3,000 ringgit. Also a lot of theory thing, talking about normal kind of 5-6 case study. But we skip all those actually textbook kind of explanation. I believe all those textbook kind of thing, you can go through the MITs or some of the renowned university. They have a lot of actually free AI classes given away. So you can look at all those available video. But what we offering, we don't talk about this theory. We go into in a practical way, how can get result. 15, 16, 17, 18, 22nd of March. Every day, 2 o'clock to 6 o'clock, only 250 ringgit. I'll explain to you about some the even good news about discounting side. I'll let him talk about that later. But you say I'm coming from commercial world. After 22nd of March, we'll give another 3 more days. Tell you that how you're going to deploy this thing using Raspberry Pi for your commercial production. Now, this commercial one is credible under HRD Corp. If a company is contributing to HRD Corp, you have 10 employees and above, quite likely you are contributing, you can get fully sponsored. So this is usually our 6 stages. Now, I will not want to talk about too much. I pass the time to Desmond, like he explained a little bit, then we can close the class today. Desmond.
Thank you, Peter. I think what Peter has shared with you in this 2 hours is quite informative. There's a lot of things we want to share with you, but within 2 hours, we just able to scratch the surface of what we offer in Wolfram Machine Learning. So if you are interested to be further learn about machine learning with Wolfram language, we highly encourage you to take up these training programs, which Peter mentioned just now. 5 days, each day 4 hours, and then total 20 hours. We include a lot of real project, real case studies. I think we have around probably 15 of them. So if you are want to find out more, we'll share with you in the chat room about the link. So that is the link that probably I'll bring you to the website. Let me show you the website. This is the page. So we have a lot of other module, but if you are just looking at the machine learning, this is the module B. Like Peter I mentioned, we started on the March 15, 16, 17, 18, and 22nd. So it all takes 4 hours, 2 o'clock to 6 o'clock. We offer to commercial in the market is 3,800 per person. But this is a special case for all the academic people. So we only pay 250. And also on top of that one, for today only, we also give the last chance for 10% discount. So if you sign up today with the registration now, the promo code is OFF10ML, which stand for machine learning. I put in a chat room about this promo code. So this promo code is valid for today only. If you are interested to learn more about the machine learning in this course. And there will be a course syllabus available. You can check out and download this to see what is included in this training. So let's say you click on this syllabus, you can see what we have been offered in this training course. We have run this for the past 1.5 years, and we have over 100 of participants have gone through with us. They are happy with what they have been able to learn in this course, and many of them still keep coming back to us with their real project or real works that going on with the machine learning. So they are also, we have no really charging for the consultation fee or anything, but we actually want to help out with the academic people. That's why you see that there is a day 1, what's in the day 2, what's in the day 3, all is this down in the syllabus. So you can see how we actually carefully plan out the syllabus for you to catch up from one level to another. And those are also some of the feedback from the participants. You can see that there's a lot of different university academics they actually gone through with us before. So I hope you will grab this opportunity to take up this one. And also not only that you can get a 10% discount, if you have your friends that are coming together with you in this course, if they can sign up with a referral code, either they use a promo code of 10 machine learning to get 10%, or you'll get your friend to put your name as a referral. Then he will get 5% discount. And on top of that, you also will earn another 10% referral fee. So for instance, 250, you get 5% off from 250, and you also get a 25 ringgit as a referral fee, our token to you. All right. And of course, lastly, before I forgot, the certificate of attendance. Yes, you will get your certificate of attendance for today by going through the link in the chat room. So fill in your names, then you should be able to get the certificate emailed to you in a short while. This link will be active for the next 10 minutes, so that take the time to fill up the form. If you have any question, feel free to email us. I leave our email in the chat room, info@oemscorp.com, or you also can come back to us through the WhatsApp that you received all the information from us previously. Okay. Sorry, I got a question from Dr. Zainidi. He asked, where is the forms? You mean the certificate of attendance or the sign-up form for the training? If for the sign-up form for the training, yeah, we got 2 links. You can go to our website for the training program, or the sign-up form for the certificate in the chat room as well. All right. With that, I think we will close the class for today. And for those that if you want to review, as we mentioned, we will send out the recorded video to you all probably this afternoon. You can probably watch it again, or maybe you can share to those people that you know they might be interested with the machine learning. There is an opportunity as well. Okay, thank you so much, and I hope to see you in the training.
Desmond?
Thank you. Bye-bye.
I got a question, Desmond.
Yes. Yes.
There's a question regarding the license.
Mhm.
Is it a lifetime or it has to be renewed?
Which license? For the university that they already have the license, which they already signed an agreement with Wolfram. The university normally they will sign up for 3 years and they renew every 3 years. So if you are the lecturer or staff of that university, for instance, right now it's USM, UM, and Monash University, they actually get extended their license every time the management extend their license. And for those that you are not attached to the 3 universities that I mentioned just now, you actually will get the 30 days full license, full feature license that we provide to you. If you in the sign up form you check you want the trial license, we give you the 30 days. After still want to try it out, you can always write back to us. We'll try to give you another 30 days. Or if you sign up for a training course, of course, we'll provide the license for you throughout the training as well.
Yeah, so because I think some of the campuses are asking the IPGM to buy the license, so we are not too sure what will be the terms, you see, whether that means we're going to get only a single user license, or is it going to be multiple?
Okay. Yeah. IPGM last night did ask about the licensing. So we also proposing a license like what USM or or Monash have. That means all the IPGM students and lecturers should have their individual license without paying from their own. So it will be considered as a group campus license. Yeah.
Group campus, that means each campus one license, or is it the whole IPGM?
The whole, every student and lecturer from the IPGM, they will get their personal license. Not one, but all of them. Yeah. So if you are teaching the class, all the students also can access to the Wolfram Mathematica at their own PC.
At their own PC lah. Okay.
Yeah.
Okay. So that one will be IPGM will be the one working out the agreement with you all, huh?
Yeah, that's right. But we still haven't, I think it's still in progress. We haven't had concrete feedback from them yet. And if
because today they're asking us about whether we want besides all the software lah. So we are not sure how to answer that one, because not sure whether it's a single user or multiple lah. Okay.
Yeah. Multiple will be much more easier for academics, because if you're single, as a lecturer, you have the access, but you really difficult to get the student actually to involve if they have no access to the software as well. So normally for academic will be like a whole campus license will be much more effective, yeah, and much more lower price compared to having a single license.
Okay. So maybe I leave it to the IPGM to do the agreement with you all, huh?
Thank you, Madeline.
Okay, thanks.